Unit 11, Lesson 2, Question 12. Before I actually attempt to simplify this trig expression, I want to remind you, if I said a squared minus b squared, I'm hoping you would remember that that's a plus b times a minus b. Example, 9x squared minus 4 is 3x plus 2 and 3x minus 2. It's a concept of difference of squares. Now what if I said a to the fourth minus b to the fourth? Okay, that would break into a squared and b squared and b squared. So it'd be a squared plus b squared and a squared minus b squared. And then this would still break down to a plus b and a minus b. Okay, that's just a little refresher. So let's look back up here. What does this break into? Sine squared x plus cosine squared x and sine squared x minus cosine squared x. Front, outside, inside, last. The fronts give you sine to the fourth x. The insides and the outsides are additive inverses. They cancel out. This is a positive sine squared cosine squared. This is a negative sine squared cosine squared. And then last, when we FOIL the very last, we'd get a negative cosine to the fourth. Okay, I also know that the number one trig identity we remember is that cosine squared plus sine squared is 1. So I can replace this with the 1. 1 times this quantity is simply sine squared x minus cosine squared x. But am I done? I think I can do more. I think this breaks into the sine of x plus the cosine of x and the sine of x minus the cosine of x. There's sine squared. The inside and the outside are going to cancel, and there's cosine squared. So either one of these is equivalent. I personally like the bottom option as the most simplified.